Hey, what's up guys? My name is Cherno. Welcome back to my Game Engine series. So I'll be completely honest with you guys, with everything that's been going on lately, I'm completely unprepared for today's video. But that's okay, because we're gonna have a nice chill session and we're just gonna slap in batch rendering into Hazel, as if it's like no big deal, because it's really not. We're probably not gonna get the whole batch render completely done today, because that video will probably be like an hour and a half, but I do basically want to take our existing renderer 2D API and kind of move it into more of like a batch rendering situation. Side note, you can see that I am not in the new office because that building is likely getting shut down because of everything that's been going on. So just fantastic really that I moved everything into that office. Now we're back here, back at home, back at the Cherno home. So hope you guys are all keeping safe. Don't do anything stupid. Try and limit your time outside. Don't underestimate this thing because it really is kind of a very big deal. If you didn't catch the last episode, I did put up an overview of Hazel 2020, so check out that video if you haven't already. Basically, it's just me going through what our plans are for this year. I think it's definitely important to know the direction in which the project you're working on is heading, whether that be like something that you're fully working on or if it's something that you're kind of contributing to, because if you don't have a sense of direction, it's kind of difficult to actually, create a software project. Anyway, let's kind of get right into this. Not really much that needs to be said. Batch rendering is something that we've kind of talked about. If you're new to batch rendering, and I'm not going to try and explain too much of the code that I'm going to be writing here today because I already have. There's a series called Batch Rendering. There's the first video. Check it out. It's like 4 or 5 episodes or something like that. It'll teach you everything about batch rendering and how to kind of, batch together 2D quads so that you can all render them in one draw call. Check that out because that's what we're going to be putting into Hazel today. Let's jump in. Okay, so this is the current state of renderer 2D. As I mentioned, we're just going to have a really nice chill session here. This is what we ended up with last time. I think the last time we actually touched the code base was to move across all of the kind of changes that I had to make to Hazel when I was writing that game in an hour thing. If you guys haven't seen that video where I make a game in an hour using Hazel, check it out up there. Because I did actually practically use Hazel to build a game, I was able to realize like what needed to be added to Hazel, and then we kind of added all of that stuff, and that's what this is. So that's why we have this kind of rotated quad and a normal quad and checkerboard and all of that stuff. So that's all happening within Sandbox 2D. Ignore these errors, that's just Visual Studio. And then what I want to do today, and as I mentioned last time, we don't want to touch this API at all. Begin scene, end scene, we've got that because it's important to kind of create a context for our rendering scene. So in other words, our context at the moment is just simply a camera. So since we have a camera, we need to have kind of this begin scene, end scene thing. And then we have all of our primitives that we draw within that. So what I'm going to do is conveniently use the beginning and ending of a scene as an attempt to kind of batch everything together into one draw call. Now, obviously, if your scene is excessively large, so for example, let's just throw a number out there, above 10,000 quads, then maybe we want to kind of divide that into multiple draw calls. I don't know exactly what the right number is. It's really important to run some tests on your target platform, on your target hardware, because if you just kind of throw numbers out there like, yeah, let's just batch together 100,000 quads into one draw call, like it's difficult to kind of just set a number like that. And I certainly don't have a number. So this is probably something that we'll play around with and we'll see what works. For now, we'll set it to 10,000 because I think that's a reasonable number. And also we probably won't be drawing much more than that anyway. So the idea is that when you do begin scene, when you do end scene, we'll create one kind of batch, right? So it will attempt to render everything in one draw call. However, if within that same begin scene, end scene, you exceed that limit of 10,000 quads, then it's simply going to flush everything it's got and then start again, start a new batch. So in other words, it'll start a new draw call. So if you try and render, let's just say 22,000 quads between one begin scene and end scene, that should come out as 3 draw calls. Probably subject to other things such as textures. Like if you want to use 100 different textures for that, it's probably going to end up being more batches. So with that being said, let's go to our renderer 2D and see what we actually need to do. This is kind of our struct of all of our data. We've currently got a quad vertex array because I guess I wrote this in a little bit of a way that both ensured that we would probably get around to batch rendering one day, but also because we kind of use that quad as our template to render anything that we need to currently render. It's just that it happens to be a separate draw call at the moment. So really what we need to do is change the way that our vertex buffer gets created. At the moment, when we create our vertex buffer, you can see that we immediately push in those square vertices. They kind of go from negative 0.5 to positive 0.5, so we get a 1 by 1 unit quad or a square. So we're going to delete all of that because obviously the idea is we're going to have a dynamic vertex buffer instead. And then instead of creating a vertex buffer like this, we really just need to create a vertex buffer that has a given size. So this is interesting because I'm not sure that Hazel's API, like for buffer, supports that because we haven't had to deal with that yet, obviously. So yeah, the only way that we can create a vertex buffer at the moment is by passing a pointer to a bunch of floats and then also a size. So we need to extend that API so that we can actually just create a vertex buffer based on a size. So we'll just say uint32 size, and we'll kind of make that, I guess, as the first create function since it's only got one parameter. I like to kind of organize it that way. Since we're here as well, we might as well take a look at index buffer. So yeah, I mean, for index buffer, this stays exactly the same. We don't really care about that. It's important to note that currently Hazel only supports 32-bit index buffers. So this is important because just in case you want to render like a 16-bit index buffer, which is probably something we'll add in the future, we need to just kind of take that into account. So I really hope I don't forget that because I've made that mistake before. Okay, cool. So moving on, let's kind of implement this, and then let's get rid of these Hazels. Let's kind of just copy and paste, I guess this, and actually let's move this up here. While I'm typing this code, how are you guys doing? Write a comment below. Let me know what your life is like nowadays with all the crazy stuff going on. Because, yeah, interesting times. Okay, so we need to grab this and get rid of that, and then we'll just have a size. So if that happens, right, let's see. This is our kind of creation, and I guess I'll add the profile to it as well. This is our current vertex buffer creation. What we need to do is basically do the same thing as we do here, except the only difference is we pass in null pointer for our data pointer. So we're just creating this kind of vertex buffer, which has a size, but actually no data. And so this last parameter is the hint that we give to OpenGL as to how we're going to use the data. This is just a hint, meaning that if I leave this as static draw, it's still going to work. It's just likely going to be slower because OpenGL is not going to expect us to continue writing data to that buffer every frame. So by changing it to dynamic draw, we're basically saying that data is likely to be entering the buffer or being written to the buffer every frame. So that's obviously what we want, since we'll be continually updating that buffer every single frame. Okay, I think that's about it. That's really all we need to do. Just make sure that you don't pass any data, make sure it's dynamic draw, and the size remains the same. So now we should have the ability to kind of create this based on what we specify the kind of maximum number of quads to be. So again, we said we wanted 10,000 quads. So I'm just going to write const uint32t, max quads we'll set to maybe, well, 10,000 because that's what we kind of agreed on. So since we want the max quads at 10,000, we'll set the max vertices to be max quads times 4 because we have 4 vertices per quad. We'll set the max indices to be max quads times 6 because we have 6 indices per quad. And I think that's probably all we need. Now, max meaning, I know I've written max here, even though max is kind of like the size. It's just because if it exceeds this, it's going to have to be a draw, like a new draw call. So this is essentially the maximum amount of vertices that we can have, or the maximum amount of indices we can have per a single draw call. So not like the maximum for the renderer and then it just explodes. It's just the maximum that we can have for a given draw call. Okay, awesome. So one other thing I'll do just quickly as a little side thing. Well, I want to do two things actually, just looking at this code, because I'm not sure why I wrote it this way, and maybe I'm just being stupid right now, but so I call this storage, which I should just call it data because it is s_data is how we're treating it. So I'm going to rename this to renderer2d data. Maybe I just didn't like that double D there or something, but anyway, renderer2d data because I usually call these things data. Also, there's really no reason for this to be like a dynamic allocation here, like as in it just doesn't need to be. I think the only time the only reason why I may have done that is just to control the lifetime, because you can see we deleted and shut down, we created here. But honestly, with the fact that this does not ever get, this data is just a struct filled with data. It does not get initialized until init. I think that it's fine just as a little bit of a cleanup thing to actually just move that out from being a pointer to just being like a kind of statically allocated object here. Because it's not like, again, it's not like if this was doing OpenGL stuff, then yeah, we would probably want to explicitly instantiate or initialize this kind of data within the init function. But in this case, we just really don't need to. So for now, at least, again, may change in the future, but for now, we're just going to get rid of that. And what that means is that we'll have to replace all of this with sdata dot. All right, cool. So there we go. Just a little bit of housekeeping, I guess. Okay, so max vertices is probably what we're looking at. So this needs to be a size, and I believe this size is in bytes. So we need to basically do sdata.max vertices times the size of every vertex. So we don't have a vertex definition, do we? Do we really not? Like, what? How did we... Maybe I delete... Oh, yeah, we just used floats, didn't we? Okay, well, in that case, we'll make a struct called quad vertex. Now, the reason I'm calling everything quad, by the way, is because this renderer will eventually support lines as well. And obviously, a line vertex is going to differ from a quad vertex. And like a line index buffer is going to differ from a quad index buffer and so on and so forth. So that's why I'm explicitly calling this quad. Okay, so what we want to do here is basically define everything that a quad is. So at the moment, we're dealing with position text coordinate. Obviously, we'll have to extend that a little bit. But for now, we'll kind of keep in that same data because this is going to be like phase one of our renderer is obviously going to try and be as simple as possible. So we'll have a position and we'll have a text coord. But in the future, obviously, you know, we'll have a color, we'll have a texture ID. We might even have like a mask ID, but we'll address masks probably in the distant future. And what else? It's probably it for now, right? Yeah, position, color. Am I missing anything? Am I missing anything important? I don't think so. All right, we'll keep that in there for now. Okay, so now that we have our quad vertex and that we're kind of creating our quad vertex buffer, important obviously that whatever we set the layout of the vertex buffer kind of corresponds to this. I'm also going to probably rename this to just be called quad VB because instead of square VB, because that's not really true. Okay, indices. So let's take a look at that. So what we want to do is basically generate a whole bunch of indices. Now, because these are likely going to be large, I think I'm going to want to actually allocate them on the heap. So what I'll do is I'll create an array of these. We'll say quad indices. How many do we want? Maybe has something to do with our constants. So that's a joke, by the way. So not a very good one either. So max indices is how many indices we obviously want. So how many is that? That's like 60,000 uint32Ts. So that's, how much is that? Like 240 kilobytes. I mean, that's still obviously permissible to have on the stack, but in case someone wants to blow that number up, it might actually cause a stack overflow. So I'd rather just dynamically allocate it here. And I definitely don't want to use vector or anything like that. So we'll just kind of remember, I guess, to delete these. Not a big deal at all. Okay, so we have quad indices. Let's kind of push that in here. It's really important to know the lifetime of this, by the way. I do kind of... The reason this code doesn't look that great to me is because this is obviously assuming that these indices, this data, gets uploaded to the GPU immediately. Because if it doesn't, right, and it hits this, if it gets queued or something like that, it's not going to ever be uploaded. Like, you're going to crash your program because you've deleted the data. You've freed the data. So it's a little bit dangerous. I understand that, which is why it's definitely better to kind of reference count everything, and maybe that way, you know, you hand over a reference to this, which could be running on a different thread, like the render thread. And then when it's done with it, it releases. And since this is already released as well, you kind of get this, you know, basically this reference counting system where once the reference is a 0, nothing's holding on to it, then it deletes it. So it's kind of like a shared pointer. But anyway, we'll do this for now because we know that we don't have any threads or any queues or anything like that. Everything's done immediately. But that's just a kind of like a side note, just so that you guys keep that in mind. Okay, so this is not going to work, obviously. So what do we have? We have quad indices, and then the size is going to be sdata max indices times size of uint32. Now, this better not be the count, because I feel like it is. I feel like I always do this. So if we look at index buffer create, and we drill down here, yeah, so you can see we have count. So it's called count here. This is a huge issue. It's called count here, but I believe in here it's called size. That is a massively bad thing to do. So make sure that count means count in terms of elements and the size means size in terms of bytes. Because if you mix them up, you're going to have a bad day. So now that we know that, and yeah, I know the API is slightly inconsistent, but the idea is that we don't need this. This is not useful information because we know that the index buffer is a 32-bit index buffer, right? Meaning that it uses like 32-bit integers, not 16-bit or whatever. So that's why, you know, if you create an index buffer that is not a uint32t, but like is a uint16t or something, then you would also not need to know the size because, you know, it's 16 bits. So just a little kind of thing. Even though like part of me is almost like, maybe just leave it in there for consistency, but no, I don't want to. So there we go. And then we have, yeah, so this is our quad index buffer. We've created that, we've deleted the, oh yeah, and obviously the important part here is that when we create this index buffer, you can see that we immediately do GL buffer data, we send those indices there, and then obviously that happens before we delete them. So that's the important thing to note. Okay, white texture, we'll leave that in there. We're not gonna deal with textures for now. We're just gonna get these quads being batched together. That's pretty much it, okay? Now we need some other things here, obviously, to keep track of how many quads we're trying to draw. So I'll say uint32, we'll just say index count or quad index count. So we'll initialize that to 0. So every time we draw a quad, we're going to increment this by 6 so that we know how many indices we actually have to draw when we flush everything. Okay, so draw quad. This is the function that's going to change. So which one should we attack first? By the way, we do need a color for our quads, because I think we're currently drawing a red one and a blue one, so we might as well just add color in right now, otherwise we're not really going to, it's not really going to work very well, so maybe let's put this here, and we'll call this color. So we have position color, to do text ID. Okay, and then we have to obviously make sure that we add this to our buffer layout, a color. Alright, so this means that we should be able to render with colors, and obviously we'll have to modify our shader to make that happen as well. Okay, so our next step really is modifying these draw quad functions. Let's just start with one. We're probably not going to bother with rotation either. Rotation for batch rendering isn't particularly difficult either. All you really have to do is create a rotation matrix and then multiply every vertex of your quad with that rotation matrix, like on the CPU side, like here. And then you get your rotation being like batched and everything, because obviously you can't do that matrix multiplication inside the shader since it's all going to be one batch. But then that also brings the, I guess the other thing that we could do, which is obviously having like a transformation stack. So in other words, you can push a matrix into the stack, everything will be applied to that matrix, and then you can pop that matrix, and then your quads will no longer be affected by that matrix. And that's also something that you'd probably implement in C++. Anyway, whatever, just stuff for the future. This is the big thing though, this kind of position size color. So let's see what we want to do here. So we basically need to create and push into this vertex buffer, like 4 new vertices, right? So to make that happen, we need to actually, inside begin scene, we need to actually map the vertex buffer. So you could use GL map buffer, but it's probably a bit better to use buffer subdata for like uploading stuff. So what I'll do is we'll have quad vertex. I'll pull this up here because we need to use it. I'll have quad vertex. What should I call this? So this is our quad vertex buffer base, and then pointer. So I'll set both of these to null just to initialize them properly. And then what will happen is we basically need to allocate inside, probably when we do this, where should I put this? Maybe I will put it here, because I guess it's to do with the vertex buffer. We'll say quad vertex buffer base equals new quad vertex, and then we do sdata max vertices. So we have basically enough storage for the entire vertex buffer, right? And this is of course sdata. Okay, so then what we do is when it's time to begin scene, right, we set the pointer equal to the base. So now we can write into this and we can freely increment this, and obviously we don't lose track of where the base of our memory allocation is. And then in end scene, this is where we need to actually do the flushing. So I don't think our API supports that either, so we'll have to set that up in a minute. But let's do this first. So now that we've got, where's our draw quad function that we're actually using? I think it's this one, yeah. Okay. So we basically get the buffer pointer, right? And then into here, we can write all of our data because this should be at the position of the next vertex that we write into. So into here, we need to push back the position, and we need to obviously do this per vertex. So for the first vertex, we're going to push back the position, the color. The color is going to be the same for all vertices. And then the text coord, which we don't really need it here. But I guess there's no harm in having it. Maybe, you know, it's some math operations that we can get away with not using, because obviously we're trying to draw a colored quad, a flat colored quad, not a textured quad here. But we'll just set them up anyway so we can copy them easily later. So this is the bottom left. So the texture coordinate is 0, 0. I guess I'll write them as floats. The position is just whatever the position is, because we define the position from the bottom left. Is that right, or do we want to define the position from the middle? That's also a good question to ask, and I don't know what the answer is yet. We'll see. Okay, that's always a common kind of question. Okay, let's copy this 4 times. So we have we're going counterclockwise, right? So the next one would be the kind of bottom right. So this becomes, and this is a 3-component position, isn't it? Yeah. Okay, so this becomes position.x plus size x, and then just position.y, and 0. This one over here becomes both x and y. And this one here becomes just y. So this is the top left. And then we obviously get rid of these dual semicolons. Texture coordinates, so they kind of go with the variables. So in other words, if there's a plus size, you add it. You change that coordinate to 1, so that's an easy way to think about that. Okay, that's it. So obviously positive, by the way, is like going up. Going down is negative in the y-axis. Okay, so there we go, that's it. So now that we've done that, we don't need to worry about color anymore. The tiling factor is still important, but that's for our textures anyway, so I don't know, we'll keep that in there, but you know, we don't really need it. White texture bind, this stuff is meaningless to have here. I'm actually going to comment it out because obviously we're not going to be drawing indexed at all here. That's going to be happening like when we flush our renderer at the end of our batch. Okay, so that's done. So this is really the only function that's going to work at the moment, and I'm okay with that. Let's ignore all the other ones. Let's go to end scene, because that's what we're interested in. So end scene means that we've ended our scene. So in other words, it should actually do the rendering here. Now, what I usually do is I write a function called flush. The reason being that, like, you know, for profiling and for like other reasons, it's usually just nice to, you know, split your code up into different sections, I guess. That's why we usually like to use functions. That's the only reason, but at the moment we'll have flush being called from endscene. Oh no, actually the other really important part is that I mean, endscene could honestly do flush all the time, but we're also going to have to handle the case of if we've exceeded the amount of vertices that we can render. And by the way, one thing I forgot was to increment the it's not even showing up. What do we call it? Our quad index count. Maybe it did show up. To be plus equals 6, okay? And then actually, I guess in begin scene, we'll probably want to set the quad index count to 0. So we're basically resetting everything here. Okay, cool. So what is end scene going to do? So end scene is going to actually upload the data to the GPU. So it basically needs to do quad vertex buffer, which we don't have, so we really need to retain that. I'll add that up here. We have quad vertex array, but I'll also add quad vertex buffer. So that's what we'll use instead of creating one here. So this becomes S data, oops, S data quad vertex buffer. There we go. And then that way we can just hopefully do set data, or I don't know, copy data. What's a good name for this function? I think set data is going to be fine for now. I'm not going to get too hung up with what to call things because that's a trap. So we need to set the data to basically, we need to figure out what, well, we want to set it to quad vertex buffer base, but the size is going to be interesting because the size of this is going to be, and I can call this the data size, that's going to be the quad buffer pointer minus quad buffer base. But obviously if you do the subtraction like this, it's just going to tell you the number of elements because these are quad vertices. So you actually have to cast these to basically something that is 1 byte large. So I'm going to cast this to a uint8t because that of course is 1 byte. And then that way, when we do the subtraction, we actually get how many elements it takes up in terms of bytes, which is what we want. All right, data size is in there. That's it. That's all we have to do. So set data, we need to implement that function. Obviously it doesn't exist. So let's go to our buffer class. And then over here, we'll have a virtual void set data. So this is going to take in a void pointer of data. I guess we can make it a constant void pointer. And then it's also going to take in a uint32t size. And we'll set that equal to 0, of course, and we'll copy it for our OpenGL buffer class. We'll paste it. So this was after get layout, set layout. Let's move it up because it's probably more important than the layout. Or maybe not. I guess not, but it doesn't matter. I want to have it up here. Set that to override, and then we'll implement the function. Okay, so set data, what's that going to do? So basically what we need to do is bind the buffer, GL array buffer, and the buffer being mrenderer ID. And then we need to GL buffer sub data. Okay, so the target obviously is array buffer. The offset is 0. So we don't provide an offset at the moment. I don't think that's strictly, well, it might be nice to have because this is obviously the target buffer offset, but since we don't have a use case for it yet, I'm not going to add it at the moment. Size is going to be size and data is going to be data. So it's pretty simple stuff. All right, and I think that is it. So once we've set the data, we're happy to flush now. So what we need to do is basically just execute the draw call. So the same way that we do render a draw indexed, or the same way that we did it here, render command it was called. Render command, draw indexed, we basically just draw our vertex array. So S data vertex array. Now this is probably going to be a trap because quad vertex array, because obviously this doesn't take in the index count, which is not good. So what does this actually do? Draw indexed, is this even the right function? OpenGL render API. Draw index takes in the vertex array. Wow, so much interaction. Yeah, so this does an unsigned int, and it obviously draws the entire index buffer, which is not gonna work for us. So what we really want to do is probably extend this slightly, and we can do it pretty easily. We just need to actually find the right file here. What I want to do is I'm just going to literally add a uint32t count, or rather index count, and we'll set that to 0 by default. So in other words, what we're doing is basically saying that if it's, well, what we're going to write is some code that says that if it's 0, then we're going to just use the vertex arrays, like the full index count. But if we specify an index count that's other than 0, then obviously that's how many we want. So we'll have our index count here. So basically what I mean is uint32t count, we'll say, is going to be if index count is 0, right? Or if it's not 0, maybe we can just write code like this to keep it a bit cleaner. Then we can use the index buffer count. Otherwise, we'll use index count. So that way we can actually tell. So if the count's been set, then we use the count. And then that makes it nice and simple. So that means that we can now just simply write S data quad index count, and we should be good. So I think that that's good, and I might have to extend it here as well, unfortunately. because, yeah, whatever, because of the way that this is written. Okay, there we go. Let's compile our code. I don't know if this is going to work. They probably missed a bunch of stuff. So position, color, and text coord is what it looks like. Let's take a look at our shader, because that's probably going to need modification. So what shader are we actually using? Texture.glsl is the shader. So let's kind of extend this. Let's add a color. This will be a vec4. We'll keep our text coord there. We need to send the color. So we have a transform. That's not going to exist anymore. So we'll get rid of that. We'll have an out vec for the color. And that will obviously be a color. We'll make sure that we take that in as well. The color. And then what we'll do is, at the moment we're not supporting textures. I'll comment that out. We'll say color equals vColor, basically. So you specify color and that's it. And that should work, I think, pretty well for us. So we'll ignore everything else, because obviously next time we're gonna rewrite the whole thing. But for now, we should get something on the screen, hopefully. Is that really all we need? So that was simple. So let's go into Sandbox 2D. And so we'll do begin scene. We won't draw anything rotated. We won't draw anything with a texture. Let's draw this same quad, but just not rotated. So we'll just do a draw quad. We'll get rid of the rotation, just so that we get two different colors. And we do end scene, which does the upload and then does the flush, which actually draws everything. I don't know. Let's just hit F5 and see what happens, honestly. All right, and as you can see, we get nothing on the screen. That's exciting. So apparently that did not work as well as I intended. So let's diagnose this and see what went wrong. I'm just going to check this stuff really quickly just for sanity's sake. So we have all of our indices here. Oh, we didn't generate any indices. Wow, I just forgot about that. So what are we setting our indices to? An empty array. Beautiful. Let's go through this and actually set them properly. So how many indices do we want? We want max indices. So we'll say sdata max indices, and then we'll increment this by 6, and then we'll just set them up here. So we'll have an offset, and then we'll just say quad indices I plus 0 equals, so we have our offset plus 0 here. So the idea is, we want 6 of these. So 0, 1, 2, 2, 3, 0, and then we increment our offset by 4. Just so that the next one's going to be like, 4, 5, 6, 6, 7, 4. And then obviously here we just write straight into 1, 2, 3, 4, 5. Okay, that should be good. And that should go all the way up to max indices. These obviously need to be divisible by 6, and they will be, because it's times 6 here. So we're obviously relying on that, but I think that's safe. Okay, and then we upload the right data. So let's see if that makes a difference. That might make it work. Awesome, there we go. So our camera still works, everything still works, but these two are now drawn in a single draw call, or at least they should be drawn in a single draw call. So that is now the beginning of batch rendering in Hazel. So what we'll do next time is basically extend this API so that we can also draw textures and deal with like our tiling or whatever else we had there in our default shader. We'll have to kind of rewrite our shader and make sure that it works with that. And we'll also probably test out that 10,000 quad limit. And we also need to write some code that obviously will, if it exceeds 10,000, will flush the existing kind of batch, I guess, and then start a new batch with the rest of everything. And I think it's going to take a little bit of time to get textures to work properly, just because, yeah, we have to make sure that we handle texture slots correctly. We handle up to 32 textures. We need to have that base white texture, and we need to extend the vertex attributes and everything to actually have a texture ID. Anyway, I hope you guys enjoyed this video. I'm glad to be back. I'm doing a few things new this month. So first of all, patreon.com/thecherno is the best way to help support this series, and especially in a time like this, like, I really appreciate you guys. I really appreciate your support. I'm going to try and be as productive and as optimistic as possible during this time and try and deliver as much content as possible. And part of that is tomorrow what I'm doing is for patrons, I'm starting live streaming. So I'll be live streaming myself working on the development branch of Hazel, so all the 3D fun stuff, live for like, I expect it'll be like a 2 to 3 hour stream tomorrow. And I'm going to try and do that at least once a week. And depending on how much you guys like it, how successful it is, I'm going to try and basically just stream myself during the day working on whatever it is I'm working on. So that's something new that I'm doing. I'm super excited. I think it'll probably make me a lot more productive, and hopefully it'll make kind of, I guess, you guys more involved with what I'm doing, because I'll be able to interact with the stream, and the streams are going to stay online so that you can watch them later if you missed them or anything like that. So patreon.com/the Cherno. Huge thank you to all of you for watching all of my videos, and I will see you guys next time. Goodbye.